Welcome to The Explainer. Today, we are going to strip chemistry down to the absolute essentials. We're going to build a super solid foundation that'll help you crush your next exam and really get how the world works on a molecular level. Feeling that pre-exam heat? Yeah, we get it. But don't you worry, you are in exactly the right place. We're about to turn that stress into confidence by just nailing the core concepts one by one.
All right, let's just dive right in. Forget spending hours cramming from a textbook. The next few minutes are going to give you that solid framework you need. Let's do this.
Okay, first things first, we have to talk about matter. Why? Because it's everything. Understanding how chemists sort and classify it is the absolute first step to thinking like a chemist. So what is it? The definition is actually super simple. If it takes up space and has weight, it's matter. Your phone, the air you're breathing right now, your coffee, it's all matter. It's the physical stuff the universe is made of. Now, chemists like to keep things organized, so they classify matter in two main ways. The first is physical. Is it a solid, a liquid, or a gas? Easy. But the second way, the chemical way, is where we dig a little deeper. Is it a pure substance, like pure gold or pure water? Or is it a mixture, where a bunch of different things are just tossed together?
Let's look closer at those mixtures. If you stir salt into water, it dissolves, right? You can't see the individual salt bits anymore. The whole thing looks the same. That's a homogeneous mixture. But if you mix sand and water, you can totally see the sand. The parts are still distinct. That is a heterogeneous mixture. One is perfectly blended, the other is clearly not.
All right, next up, to actually measure and talk about all this matter, scientists needed a common language. Imagine trying to build furniture with someone who only uses inches while you only use centimeters. It would be a disaster. That's why we have the International System of Units, or SI units. It makes sure everyone is on the same page. These 7 units right here are the alphabet for all of science. They're all important, but for chemistry, you're going to live and breathe a couple of these. Specifically, the kilogram for mass, and the most important one of all, the mole for the amount of substance. The mole is such a huge deal, it's getting its own section. And here is a major pro tip for your exams, a way to not lose easy points. You have to be precise with your units. Look at this common mistake. You either write out the full words, joules per mole, or you use only the symbols. You never, ever mix them. It's a tiny detail, but it shows you really speak the language. And that brings us to the absolute star of the show, the mole. Seriously, if you want to get chemistry, you have to get the mole. And no, not the furry animal. Think of it like a dozen. A dozen means 12, right? Well, the mole is just the chemist's version of a dozen, for a mind-blowingly huge number of particles. This is the big, giant problem, isn't it? We can't just line up atoms and count them. They're way too small. So how in the world do we measure them out for a reaction? Well, chemists came up with a brilliant solution. Okay, the official definition looks a little intimidating, but don't let it fool you. The idea is really simple. Scientists just needed a reference point, so they picked something common and stable, carbon-12. And they basically said, let's take exactly 12 grams of this, figure out how many atoms are inside, and we'll call that massive number 1 mole. That's it. It's the bridge that connects the mass we can weigh in a lab to the atoms we can't see. And this is the magic number, Avogadro's constant. 1 mole of anything, whether it's atoms of iron, molecules of water, whatever, has this many particles in it. It is a ridiculously huge number, and it's probably the most important number you'll use to go from the macro world of grams to the micro world of atoms. So, here's your practical toolkit, your mole calculation cheat sheet. These 3 formulas are your new best friends. If you have the mass of something, you divide by its molar mass to get moles. If you have a gas at standard conditions, or STP, you just divide its volume by 22.4. And if you somehow know the number of particles, you divide by Avogadro's number. Get these 3 down, and you've got this. Okay, so now that we can count our ingredients using the mole, we can finally start cooking. And that is all stoichiometry is. It's just a fancy word for the math behind chemical recipes. Look at this balanced equation. Don't see symbols, see a recipe card. Those big numbers out front, the coefficients, they tell you the ratio. This recipe is telling you crystal clear, for every 1 mole of nitrogen, you need exactly 3 moles of hydrogen. And if you have that, you'll produce exactly 2 moles of ammonia. It's a perfect ratio. But life isn't always perfect, is it? What happens when you don't have that perfect ratio? That's where the limiting reagent comes in. It is simply the ingredient that you want out of first. Think about making sandwiches. If you have 10 slices of bread, but only enough cheese for 3 sandwiches, the cheese is your limiting reagent. It limits how much you can make. It's the exact same idea in chemistry.
So how do you find the limiting reagent with math? It is so simple, I promise. It's 2 steps. For each ingredient, your reactant, you take the moles you have and divide it by its recipe number, the coefficient from the balanced equation. So here, reactant A gets a score of 10. Reactant B gets a score of 2. And the rule is simple. The smaller number wins. B is our limiting reactant. The whole reaction will grind to a halt as soon as all of B is used up.
Okay, we have covered a ton of ground. So let's lock it all in. We're going to do a super fast lightning round revision of the biggest takeaways for your exam. All right, let's drill this. 1. Matter is sorted physically and chemically. Got it. 2. The unit for counting particles? The mole. It's key. 3. The magic number for the mole? Avogadro's number, 6.022 times 10 to the 23rd. 4. 1 mole of gas at STP, 22.4 liters, always. 5. Stoichiometry is just reading the recipe ratios from the balanced equation. And 6. The limiting reagent, the one that runs out first. Find it by dividing the moles you have by the coefficient. The lowest number is your answer. That is your whole game. And there you have it, the building blocks of chemistry. From what stuff is, to how to count it, to how to cook with it. You're not just memorizing facts anymore, you have the tools, you have the concepts. You're all set. So the only question left is, are you ready to go solve the problem? You've got this.